Hello, integrated math students. Welcome to the Chapter 5 test solutions. At any point, feel free to pause this video to do your corrections and then resume where you left off. Okay, so in the first problem right here, we are to identify if it's arithmetic, geometric, or neither. And if it is arithmetic or geometric, we'll identify the common difference or common ratio. So this first sequence, you see a multiplier happening of times 2 times 2 times 2. So that means this is a geometric sequence, and that common multiplier or common ratio is times 2. For part B, you'll see we're multiplying by 1/3. Now you might think of it as dividing by 3, but remember we're thinking of a multiplier. So times 1/3, which would also make this geometric, with that common ratio of times 1/3. And finally, for part C, this one is neither arithmetic nor geometric because there is no common difference and there is no common ratio or multiplier. For number 2, we have a sequence, and you can see we're adding 5 each time, so our common difference is 5. Now we're tasked with writing an explicit and recursive equation to represent it. So the explicit will follow this format of your difference times n plus t of 0. So our explicit arithmetic equation will be 5 times n plus, working our pattern backwards by subtracting 5, plus -8, or you could put -8 would be fine. Now that's our arithmetic explicit. Let's take a look at our arithmetic recursive. So our next term in line, or t of n plus 1, equals our current term, t of n, plus your common difference of 5. And the other piece you need is that first term value is -3. So there is your explicit, and here is your recursive. Now, using one of those equations, let's find the 100th term in the sequence. We would definitely use the explicit because you can find any term in the sequence. Recursive limits you to only finding the next term in line. So if you wanted the 100th, you would need to know the 99th term. So we'll plug in 100 for n, so that means position, and we'll do 5 times 100 minus 8, or 500 minus 8, which gives us 492 is the 100th term in the sequence. Okay, for part C, is 242 a term in the sequence? Now remember, a term is t of n. So we're going to replace 242 in for t of n, and we're going to solve for n. And sequences have whole number positions, so 1, 2, 3, 4, 5, 6th term, 7th term. So as we solve for n, we're going to look to see, are we going to get a whole number for n or not? So we'll add 8 on both sides, giving us 250 equals 5n. And when we divide by 5 on both sides, we're going to get n is equal to 50. So that 242 is the 50th term in the sequence. All right, for number 3, we have to write an equation in slope-intercept form for the following information. We just have 2 points, so I know we need to find the slope. So I've already got the slope equation and my points labeled, so let's just plug the numbers in. 11 minus 6 on top, and 7 minus a -5, so they'll turn into adding a positive. So that's 5 over 12. That is the value of our slope. Now we're going to write down what we know so far. Our slope is 5/12, and we don't know b. But taking one of these 2 points, we're going to plug it in for x and for y. So I'm just going to grab the first point. It doesn't matter which one. I'm going to put 6 in place of y. And in place of x, I'm going to put a -5. And now we're going to work our way and solve for b. So I'm going to fast forward a little bit here. All right, we fast forward a little bit. And over here in blue, you'll see me adding 25/12 to 6 over 1, which means I need common denominators, and I got 97/12 is my y-intercept. And that's the same thing as 8 1/12, or if you want to write it as a decimal, you would have to approximate it. So we're not going to do that. We're going to leave it as a fraction. So our final equation is going to be y equals 5/12 times x plus, you can write 97/12 or 8 1/12 here. That's your answer for part A. Okay, part B is a little more straightforward because you know the slope and you know the y-intercept. So we're just going to plug both those in place for slope-intercept form. Slope and your y-intercept. You've got negative 3 halves times x plus 3. And there's your answer for part B. For part C, you have a graph. So the first thing we want to do is identify the y-intercept on this graph. And note we're counting by ones here. So this is at 0, 1 is the y-intercept. And then your slope can be found by using the rise over the run. So we're going to go down 1, so negative 1, and to the right 2. So our equation is negative 1/2 times x plus 1. All right, for number 4, Ralph drops a bouncy ball off the roof while Ben records the bouncing height. Remember, the rebound ratio is the rebound height divided by the initial drop height. So as you study this table, you'll see the bouncy ball is getting less and less and less and less bouncing off the ground. So a quick check on your calculator, 375 divided by 500, you would notice that each bounce is times 0.75 or times 3/4 of the previous bounce. You can check that out on your calculator by multiplying 0.75 times each of the previous numbers. So as you go down to answer part A, would this be arithmetic or geometric? Because you're multiplying, that means it's going to be geometric. And how do you know? Because you have a common ratio. And that common ratio is your rebound ratio. It's your 0.75. For part B, what family of function does this belong to? Well, it's not linear because there's not a constant rate of change. So that makes it the exponential function family. The call sign of the exponential function family is having a multiplier for the pattern. So anytime you're multiplying by the same number, whether it's a fraction or a bigger number, it's an exponential function family. All right, and in number 5, Dylan has been operating a lemonade stand with the help of his mom in his neighborhood and is donating his earnings to charity. So we've got the data tracked for the cups of lemonade sold each day and how much money is earned. So it's purely a donation. Our job in part A is to calculate the LSRL of the data by using our Desmos LSRL tool. We're going to round our numbers to the nearest hundredth. So we're going to jump over to Desmos right now. I've already got the data put into the table. So now I'm going to look down here at the information that's important to us, which would be the slope and the y-intercept. So we have a slope of about 0.52 and a y-intercept of 1.89. So that would make that right there our least squares regression line equation that we can use to calculate to make predictions. All right, let's move on to part B. Part B states find the correlation coefficient and interpret what it means about the data, round to 4 decimal places. So let's go grab that R value. Again, using our Desmos, here it is. It's already to 4 decimal places, 0.9162. So there's our correlation coefficient. And what does that tell us? Well, let's start with the describing it. It tells us it's positive. It's very close to 1, so we would call this strong. It's linear. There are no apparent outliers, and this tells us there is a strong correlation between the cups of lemonade sold and the money earned. So the more cups sold, the more money Dylan expects to gain in donations that day. So you could write that down as well, but we're really looking for these 4 pieces right here. The correlation coefficient, you noting it's positive, it's strong, it's linear. You could mention there are no outliers as well in this situation. Okay, for part C, interpret the slope in context. So that means our slope is 0.52, and I went ahead and put it over 1. And then I slapped on there the units for the y variable, which is dollars, and the units for the x variable, which is cups of lemonade. So we're just going to write this in a sentence. So $0.52, that translates to 52 cents per 1 cup of lemonade sold. That's the expected donation that we're receiving for 1 cup of lemonade sold, about 52 cents based on our equation. All right, taking a look at the bonus. A student wants to have an arithmetic sequence, and they want a slope of 22. So that translates to they want a common difference of 22. So remember, arithmetic sequences, their explicit equations look like this. They look like slope-intercept form. Common difference times n plus t of 0. But let's first take the other information they gave us. There's other demands here. That eighth term, they want to equal 164, so we wrote that down right here. And they also want the 13th term to equal 300, so we wrote that down right here. Well, those are kind of like x and y values, so let's interpret them as such. 8, 164, and 13, 300. And let's see if the slope between those 2 points is the same as the desired slope of 22. So plug these into your slope equation. Let's crunch the numbers and fast forward this. All right, fast forwarding, I found the slope. I got 136 over 5, which translates to about 27, or exactly 27.2. And that is not equal to the desired slope of 22. So no, it's not possible to create an arithmetic sequence to fit those constraints of a slope of 22 and those other term positions and term values. Thanks for watching. I hope this helped.